So hi guys, welcome to the next question of the recursion. The question is print decreasing and increasing. So what is the question and what is our input and what is our output? So this is our input. So this is our input where we just give 3 and we have to print 3, 2, 1, 1, 2, 3. When giving input integer 3, then we have to just we have to just decrease the value to 1 and then we have to just increase the value from 1, 2, 2 to 3. Okay. So how we can approach this problem? First we have to just first you should try this question and then come up for solution. Okay, so this is a combination of previous two problem where we are decrease the value and where we are increase the value. So you can figure out what is our faith and expectation. So I'm going to solve this question and what is our approach. So you can check out what is my approach and then you can apply this approach on the code. So in this question, what is our faith? When we call n equal to 5, print decreasing with n equal to 5. Okay, so we want to print 5 4 3 2 1 1 2 3 4 5. Okay, so this is your big problem. We want to print this. And what is our smaller problem? We faith on a smaller problem. No, we faith on a smaller problem. So our smaller problem is this. This is your smaller problem. And this is your expectation. This is your expectation. This is our faith. Okay, so our smaller problem. So we faith that PID n equal to 4 will know how to print 4 3 2 1 and 1 2 3 4. Can we? So this is your faith and this is your expectation. Can we print this 5 4 3 2 1 using this faith? Can we print? Yes, we can print. We have to just print 5 before calling this and after calling this. After calling this function, we have to just print 5 before and after. So what is your formula? So what is your formula? So what is condition where faith and expectation will meet each other? So we have to just print. So sorry, we have to just print 5. We have to just print 5 before calling and after calling, like we call PID with smaller problem, which is n minus 1. Then we print 5 so that we can print this. Okay, because 5 will print 5 and this will print 4 3 2 1 1 2 3 4 and this will print 5. Okay, so that we can print this expectation using this stage, using this syntax, using this formula. So in general, what we have to do in general, PD PID n will know how to print n minus 1. PID will know how to print 1 5 4 3 2 1 to n 1 to 1 and then 1 2 3 4 5 to n. It means it will know how to print n to 1 and 1 to n. But our this is our smaller problem. PID n minus 1 will know how to print. So this is your expectation. And this is your faith. Faith is what is faith? Faith will know how to print to 1 1 minus 1 n minus 2 to 1 and how to print 1 to n minus 1, like 4 3 2 1 and then 1 2 3 4. Okay, so can we meet this faith and expectation? Yes, we can meet. We have to just print before n here. We have to just print n before this and after this n, so that we can print this n and this is the and this is equal to this n minus 1 to n minus 1. We have to just print n before calling this function. So we have to just print n and we have to call this PID n minus 1 and we have to just print again n, so that we can print 4 3 1 1 2 3 4. Okay, so how we can approach this problem? So we are going to apply this approach on the code. Okay, so we just take this value, some dot in int n equal to v. So we are just take input. So the input, and we just call our PDI function with n. Okay, and then we come up here. So what is your faith? Our faith is PDI n minus 1. PDI n minus 1. This PDI n minus 1 will know. This PDI n minus 1 will know how to print 3 to 1, 1 to 3. When we want to print 4, 3, 2, 1, 1, 2, 3, 4. So this is our faith. This function will know how to print 3 to 1, 1, 2, 3, 4. Okay. So how we can meet the expectation? This is your expectation. This is your faith. We just print 4 here and this 4 here and n equal to 4. So this we have to just print n here and n here. Okay. So we have to just call dot out dot print ln, and then here also to just call print ln and here. Okay, so this is our condition. So can we find what is your base condition? Yes, we can find our base condition. What is your base condition? So we dry run this question on the stack, so we find out what is our base conditions. Okay, so we just crop out this problem. I think something was wrong with the open board, so we can't get it. Sorry, we just opened the open board. Okay, so we just go to the problem and crop out this problem. So this is our problem, and we are going to dry run this problem so we can understand what is our base condition. Okay. So this is your stack, and this is your line number 1, and this is your line number 3, and this is your line number 3. Okay. So initially our main stack is here. We give n equal to 4, then PDI function will call with the 4 value. This PDI function will call with the n equal to 4, and then when the line number 1 will execute it of this function, then it will print 4. Okay, then it will print 4, and then when the line number 2 will run of this function, then the n whatever 4 equal to will be changed, like n equal to 4 will be changed to 3, like 4 will decrease with the 3 when the line number 2 will run and call in the next function, and the value becomes 3 and the calling with the 3 value. So here n equal to 3, and when the line number 1 will run up this function, then it will print 3, and when the line number 2 will run up this function, then it will be changed 3 to 2 and decrease with the 2 and calling in the next function with n equal to 2. And when the line number 1 will run up this function, then it will print 2, and when the line number 2 will run up this function, then the value becomes 1 and calling in the next function with value 1. And then when the line number 1 will run up this function, then it will print 1, and when the line number 2 will run up this function, then it will become 0 and calling in the next function. And this time, this is our base condition. This is our base condition where we have to return. So at that time we have to return from that position. Okay, and when we return from that position, then the line number 3 will run. This is the line number 3. up this stage, there the n equal to 1. So where we return from that condition, then we print 1 here. Okay, so that we print 1 here, and then when the line number 3 will run, and then this function will wipe out, because nothing extra will run for this function, then this function will wipe out, and the line number 3 will run when the value n equal to 2, then the line number 3 will run up this function, and then it will print 2. Okay, and this function will wipe out. And when the line number 3 will run up this function, then it will print 3 and it becomes wipe out. And when the line number 3 will run up this function, then it will print 4, because at the line number 3 we will print the value, and then it will wipe out, and also main stack also wipe out. So we print 4 3 2 1 1 2 3 4. Okay, so here we print 4 3 2 1 1 2 3 4 after executing same or function. So we have to put the base condition here. If n equal to 0, then we have to return from that condition. Okay, so we are going to put the base condition. So if n equal to 0, so we have to return from that condition. Okay, and we execute this question. So this is accepted, and we have to submit this question. So this is the correct answer. So in this question, we faith that this will know how to print a smaller problem, and then we come up to big problem, how to meet the faith and expectation. Okay, so in all questions, we have to just figure out what is your faith and expectation, so that we can solve all question of using recursion. Okay, so thank you for watching this video. Please share and subscribe the channel.